In this recording, we're going to build on what you saw in the gizmo and talk about transformations of basic sinusoids. And that's anything of the form as you see on your screen. It could be a sine or cosine wave, it doesn't really matter. We're going to look at the impacts of A, B, H, and K. We're also going to introduce some vocabulary, amplitude, period, frequency, and vertical shift. So let's take a look at this gizmo and just remind ourselves of what we knew before. If we impact the A value, if we make A bigger, the number that's here in front of the sine function, the coefficient, so you can see that the wave gets much taller, although over here your x-intercepts haven't changed at all. The amplitude of the trig function is what's affected. So the amplitude is the height above the wave. We also notice that if I were to change the k value, all right, let me make this a value a little bit smaller. All right, if I change the k value, the amplitude does not change. I want you to look down here at the bottom of the screen below the graph. Changing the k, adding something on the end, just shifts the graphs up and down. Doesn't impact the amplitude at all. So let's set the amplitude to 2, and let's increase the k value to 1. And I want you to look at what the amplitude is. It's still 2, and the point is here, therefore, that it doesn't matter that the highest point is 3. The amplitude is still the height above this nodal line. So if I were to draw a line here across the middle, okay, if I have a nodal line here across the middle here, we'd still have 2 units above that line and 2 units below that line. That's the amplitude. Next I want to look at the effect of B. So I'm going to set this back to 1. I'm going to set this back to 0. And changing B affects the period. So making B like a 2 means that I've got twice as many waves here within a 2 pi cycle, 2 pi interval. Okay, so I get twice as many waves, and you can see down here the period, well, you recognize that number, 3.14. So the period is pi. The amount distance that it takes to complete one cycle is pi. That's the period. And the frequency is how many waves it completes within a 2 pi interval. And the frequency here is 2, which corresponds to that B value. Lastly, the effect of H. I'm going to bring this back to 1. Okay. And H did what it did back when we looked at transformations in the fall. If I make H, in other words, if I look up here and I have x minus 0.5 pi, the effect of that is it shifted horizontally the graph pi over 2 units to the right. So subtracting inside the parentheses actually has a horizontal shift to the right, and obviously the reverse is true as well. So those are the conclusions that we saw from the gizmo, and now we're going to write those up formally. Okay? So on your companion packet, you're going to write down what I've got up at the top here, and then you're going to play it. These are called sinusoids. Okay, so I'm going to just kind of label this thing a sinusoid. Let's get a nice purple pen here. All right, so these are sinusoids. Bear with me, I'm new to this whole mouse setup. Alright, let's define amplitude. So amplitude is whatever values in front of the trig function. It doesn't matter if it's positive or negative. It's still the height of the wave above the midline or the nodal line. So if I have some particular shift, like let's say I were to shift, let me shoot over here, get my graph again. I'm going to shift this up 1 unit. Again, my midline, or my nodal line, is right here. It's the line that splits the graph in half. Okay? And so one way to define amplitude is take your maximum y value minus your minimum and divide by 2. Okay. Let's next define frequency of the graph. So frequency, if I were to look at this graph over here, frequency is the b value. That's the b value right here. And in the graph I've shown over here, the b value is 2. It's the number in front of x inside the parentheses. As you can see on this function, okay, there are 2 cycles. There's 1 cycle, there's 2 cycles right here. So the frequency is 2. Let's just jot that down. Frequency equals 2. Grab my pen one more time. And then my period, we'll get to that later. Okay, so the frequency tells us the number of cycles that we have in a 2 pi interval. That's always the b value, so it's the number in front of x. Next, this notion of period. Period is how long something takes to happen. Okay, just intuitively. Frequency is how often. Period is how long. And what you can see is, if we go back to the gizmo, as I increase the period, let me set this back to 0. As I increase the period, the b value, the frequency increases, but the period gets smaller. I want you to keep your eye down here on the bottom of the screen. The period gets smaller as the frequency increases. So there's an inverse variation relationship going on. As b gets bigger, the period, the amount of distance it takes to complete one cycle, decreases. Okay. So we're going to formally define period as the horizontal distance to complete one cycle. Or wave, and the definition is 2 pi over b. So in the example we were looking at over on the right hand side, the period is 2 pi over the absolute value of 2, and when you simplify that, 2 over 2 is just pi, and you can see right here the graph completes one cycle within pi radians. Alright, and the last transformation we looked at was vertical shift. This is probably the most basic one. When you add something or subtract something from the end of the function, it moves the function up or down. And it's really the y value of the nodal line or the midline. One way to think of the vertical shift is just the average of the maximum and the min. We'll get a quick example. Let's set this to 1, set this back to 1. Okay, so here's a basic sine graph shifted 1 unit up. I'm going to grab this, put this over in our notes. Okay, let's look at this function. So the nodal line that I'm referring to is the line right here. If you were to draw a horizontal line across like that, that's the nodal line, the midline. And of course it's 1 unit up above the nodal line, and it's 1 unit down below the nodal line to get to the maximum and min. And if I were to say, well, what's the average between the lowest point that's 0 and the highest point that's 2? Well, obviously the average of 0 and 2 is 1. And that's where the y value of that nodal line is. And if I were to go back to the function, the k that's added on, it's y equals sine of x plus k. What's the number that I need to put over here? Of course, that's a 1. You can see that right here. It's a 1. And so those are the transformations of a, b, h, and k of sinusoids. Thanks for watching.